Hello 108 students, Mr. McHugh here with you. Going to work on whiteboard video number 18. We're going to continue on our series of section 8.5 where we are multiplying and dividing radicals. And we're going to work on problem number 9. Again, Angela asked about this one, so this is a good example for me to illustrate how you need to use that chapter 8 table. Okay, and why I would use it. And probably at this point, hopefully you guys have seen the advantage of that, but let me try to work through that for you. So our problem here is take the cube root of a fraction, 135 divided by 4. Okay, now the idea here is go ahead and separate the radicals in the numerator and denominator, and that's what I did down here. I've got the cube root of 4. Now, class, I gotta let you know, they picked this problem with the 4 because how many students are going to forget to put the cube root in there, and what do you think that's going to say? You're going to take that as the square root of 4, and you're going to write 2, and you're going to be on the wrong track. You've got to remember you're in cubed root mode. Okay, I can't tell how many times I've done that. You got to go back and make sure if it's a cube root problem, every single one of these radical signs has got to have the cube root sign, because they pick numbers that it looks like a perfect square root, and then you fall for that trap and you put the wrong answers in. Okay, now the next challenging part of this is you look at 135, and this is where you use that chapter 8 table I was talking about. Let me come over here a little bit. And what I want you to think about is this. Look on the table. If you saw under the number 3 and the cube root of 27 is 3, you would see 27 times 5 is 135. That's how you use that table to break things apart. You go into the cube root table, which was the lower right-hand corner, and you turn around and realize that 5 times 27 is 135, and so you're going to pull out the perfect cubes. Cube root of 27. Now, look, I've left it this way with the radical signs. I haven't executed the radicals yet. Okay, set everything up. Leave the cube root of 4. Okay, now let's go ahead and simplify. Cube root of 27 is 3. Okay, cube root of 5 I brought down. Cube root of 4 I brought down. Okay, now from here, you're now ready to say, well, I'd be happy with this except for one little minor detail, and that is what? Okay, we do not care for radicals in the denominator. Okay, down low. So what do we have to do? We have to rationalize. Now let's see if we can work this process out. When you're doing cube roots, it's a little harder on the brain because we're so comfortable with square roots, but what you're going to do is, now you're only dealing with the numbers here. There's no variables in this. So 4 times what would give you a perfect cube root? I'll try to set this up for you, okay? Use your table if you need it, but 4 times what? Now you can't go, that's the next one up, and you could say 4 times, the answer of course is what, class? 2, right? So 4 times 2 equals 8. Notice I've got the cube roots in here. Okay, now what do I do with this? Do I just multiply willy-nilly or whatever? You have to maintain equivalency with your radical, meaning you need to stack. So you're going to take the cube root of 2 divided by the cube root of 2. It's like I said in the last example, that's equivalent to 1 because anything divided by itself equals 1. Okay, fine. Now what's our next step? We multiply across the numerator, we multiply across the denominator. Okay, we've done the denominator. 4 times 2 is 8. Cube root of 8. We know that's going to be a perfect cube root, but I'm leaving it that way. Be patient with your work, okay? If you start executing radicals and leaving radicals on the same line, you're going to get confused and you're going to double dip and take 2 radicals, or you're going to forget to do it. So be patient with one line at a time doing your work. Now what's going on up here, class? I have 3 times, I brought it in there, and I've got, oops, look at this, look at the mistake. I talk, I got to follow my actions here. That's not the square root of 5, right? It's supposed to be what? Cube root of 5. Okay, now I've got it in there. I've got the cube root symbol. 5 times 2 is 10. Okay, now one last step here. What's our final answer? Up in the numerator, we have to leave it alone. There's not a perfect cube. You can't pull out a perfect cube root out of 8 with factoring, multiplication. So you bring that down. Here's your 10. And of course, in the denominator, the cube root of 8 is 2. Okay, so this is your final answer, and you're good to go. Hey, in that last video, I just put a note there. I forgot to put the z to the 4th power, but I wrote it on there so you remember it. Okay, so hopefully these are helping you, and I have one more to do. Okay, take care. Bye.